Alright, so this will be the 1B Day 1 notes. This is my first time recording it from OneNote, so forgive me if we get a little rough here. What's going on is probably going to be a two-part video. For this first part, we're going to look at appreciation with just costs. So this would be something you might have seen before. So we have a factory that manufactures DVDs, and you can print them. You have a cost of $400 to operate the factory. This is regardless of how many things are produced each day. We call this a fixed cost. I always have to pay $400. So if 0 units are ordered, I still have to pay $400 based on my electricity, workers coming in, insurance costs. It's always going to be $400 each day. But then, each drive that gets ordered costs me $9 in materials to make. So if 5 drives are ordered, it's $9 in material each. So I have $45 of material plus my $400 fixed cost. So when 5 drives are ordered, it will cost $445 for me to operate the factory that day. If 20 drives are ordered, each of those is $9 in material. There's $180 plus my $400 fixed cost. This will cost me $580. Go ahead and pause the video and see if you can work ahead of me. I'm gonna see where my menu bar is for Screencast. Okay, so Screencastify won't let me pause right now, so you can either fast forward to see if you agree with this or work along with it with me. So if I'm doing 32, I would multiply my 32 by 9. You can use Desmos, do it in your head, do it on a paper. That's $288. If it was 46, I'd do my 46 times 9 to get $414. And no matter what, it costs me $400 to operate the factory that day. So on a day where 32 drives are ordered, it costs me $688 to run the factory. On a day where 46 drives are ordered, 814 drives to run the factory. Now, if it costs $850 and I want to know how many drives are ordered, I'm just going to work backwards. So I can subtract the $400 that was my fixed cost to get $450 in material cost, which if it's $9 in material per drive, I can divide that by 9 and that will get me 50 drives. Now, independent versus dependent. The sentence you want to think of is blank depends on blank. So does cost depend on how many units you ordered, or does how many units were ordered depend on the cost? Well, hopefully you see that the cost depends on how many units got ordered. Should probably get some better default colors up here. But the thing to know, we'll switch this one to orange. If I say blank depends on blank, this first blank will always be the dependent variable, which goes with your y, and the second blank will be your independent variable. Independent, which goes with your x. Now, for my equation, this is literally just what we did to get these numbers. So instead of saying y equals, because this is a cost function, I'm going to say c of x. This is just like alg 2, your f of x kind of thing. So c of x is equal to, well, I had $400 as my fixed cost, plus I had some number of items times 9. Now if I want to fix that up to look a little bit more like a standard form thing, I'll say c of x equals 9x plus 400, which you'll notice is a linear equation. Now, there we go, let's scroll. If I want to make a graph, you can put those in Desmos and it will give you an awesome graph. But I need a sketch of it. So, important things that will go in the sketch. I need to have both axes labeled. My independent variable is my x, so I'm going to say units ordered is on my x-axis, and my dependent variable is y. So I will put cost on my y-axis. And I should have some sort of title for the graph, so I will say cost of selling, what was this, hard drives? DVD drives. Ooh, we're a little bit outdated here. Alright, cost of selling DVD drives. That demand is going to go down. Alright, now, what I want to say is, if I'm not selling a lot, I'm not making a lot of money. So we can use the slope to help us make this graph kind of easily. Right now, this is my slope. And my slope is $9 increase in cost per one DVD, or one DVD drive. But selling just one at a time doesn't make a ton of sense. You wouldn't make a lot of money that way, so that's not what I want my graph to be. So I'm going to multiply this by 10 and say, hey, this would be $90 per 10 drives. And this can lead to a shortcut in the graph. So I'm going to count off and have every other box be 10 drives. 10, 20, 30, 40, 50, 60, 70, 80, 90. Now here's the trick that we want to do. I need to count by the same number. And this is telling me the easiest thing to count by would be if I could count by 90s. Well, I want to count by 90s. That sounds great. But I know I have to start at 400. And 400 is not a nice multiple of 90. But there's one trick that lets us do this. If I put a little double line there, this says, hey, there's a break in the graph. 0 was here, we're going to skip up to 400. You can skip for your very first box if and only if you draw that little double line mark showing the skip. That's super important. But if you do that, then after the 400, then I can count, I'll do this in green, I can count by 90s. So I had 400, 490, 580, 470, oops, that went the wrong way. 580 plus 90 is 670, 860, 950, 1040, 1130, 1220, 1310, 1400. So that's counting by 90s, and I'm counting by 90s because that works nicely with my slope. Now what this does is tell me at 0 drives it costs $400. At 10 drives it costs 490. At 20 drives it costs 480. By choosing to make this scale this way, it makes it so that everything lines up perfectly on the dots and you don't have to guesstimate and count by 50s and figure out where 580 is. And the thing that makes it allowed is that double line. Don't forget the arrow at the end. So let's see one more situation like this, and then I'll stop and make a second video. So first, your general linear cost formula. We're using y equals mx plus b. We do c of x to show that it's the cost. You'll have your unit cost which is your slope. Whatever the cost per unit is will end up being the slope. And then your fixed cost will end up being your y-intercept. You can take a moment, pause the video, write this part down. Okay, so second situation. I'm doing print-on-demand style business again. Blah, blah, blah. It's a 200-page textbook. That doesn't actually matter to the problem. Here's what matters. $18 per copy, $1,500 fixed cost. So right away, I know my cost. Ooh. Excuse me. That's a math team flyer. You don't need that. Alright. My cost, my C of X, is, let's check over here, unit cost times X plus fixed cost. So my unit cost is 18x plus fixed cost, and that's done. If I'm making a graph, let's do it similar to how we did before. My independent variable is the number of copies. My dependent variable is the cost. I know I want this graph to start at 1,500, so I'll put my little double slash in the 1,500. Then for what I count by, I'm going to take this $18 per one copy and multiply it by 10, because 10 copies is way more realistic. So I'll get $180 per 10 copies. So if I'm counting by tens here, this one can count by 180s. So 1,500 plus 180 is 1,680. Pull out a calculator if you need to. 1,680 plus 180 is 1,860. Plus 180 again is 2,040. Plus 180 again, 2,220. So now my points on the graph, 0 copies 1,500. 10 goes with 1,680. 20 goes with 1,860. 30 goes with 2,040. 40 goes with 2,220. And I know this is a linear function. Alright, my bell's about to ring, so we're going to do this one and leave that for later. So, calculate the cost of 115 textbooks. All I need to do is say the cost of 115 is $18 per that 115 textbooks plus my 1,500. You can put this into Desmos, and the only thing you have to be careful about in your final answer is to make sure you include units. So $3,570. And we'll leave this bottom of the page for when we get into part 2 of my video and talk about costs.